Hey, Rich. It's good to have you here, and thanks for your appreciation is appreciated.
Cool, thank you.
The have you had a chance to look at cryptofex?
I haven't. I've got it on my desktop because I've downloaded it. So I'm happy to try and share my screen for the first time and have a go, or you can share yours and show me how it works.
Well, give it a try. If there's a problem, I'll take over.
Sure. How do I share my screen in Zoom?
Okay, if you move your mouse over the Zoom screen, at the bottom of the middle is the share button, green.
Oh, there it is. Yes, thank you.
Then you have to select desktop 1 or desktop 2 if you have one, and then you hit share, the blue share button.
Got it.
There you
Can
go.
you see it? Yeah, that's good, is it? So you can see here, I've got. This is the first time I've loaded it, so but yeah, here's cryptofex.
All right.
Uh,
Unfortunately, I haven't found out how to increase the font size on cryptofex. But it doesn't matter really.
Let's just see. Yeah, I'm sorry, Jim. I can't immediately see it.
Okay, well, yeah, I can just maximize it here. Yeah, I can read it fine.
You sure? Okay, cool.
Okay, I should probably get my other glasses though. Okay, so open up Rholang examples.
Mm-hmm.
Okay, and let's look at Hello World.
Sounds good.
Well, okay, there's a lot of text below there. That's all comments. Comments.
Sure.
Slash asterisk starts the comment block.
C# style. Sorry, C++ style, yeah?
No, and the asterisk slash ends the comment.
Mm-hmm.
Okay,
good to know.
And the top line has 2 slashes, which is a comment. Line, it says a simple hello world. Okay, and then we have the actual Rholang code. 3 lines.
Yeah. Okay. So I get that the new is a new name, which is an unforgeable name, correct, which presumably from reading Greg's paper is a quoted process. Except it might not be because we're talking I/O. I appreciate that, but in theory it would be a quoted process, right?
That's correct. And this is a PowerBox function, a special thing that we're assigning to the name. But the name itself could be anything. We just make it up.
Got you. So is that like that's a built-in, is it, from PowerBox? It's like a bolt-on to enable to enable things developers need, or I/O, because that's a problem for any such language. Am I correct?
You can see the PowerBox function in back quotes. Row.io.standardout.
Ah. Okay. Yeah.
Okay, so we didn't have to use the name standard out. We could have called it out. We could have called it log.
Oh, right.
So whatever we wanted to, but the PowerBox function we're linking to the name is a special output device, physical output to the log.
Physical output, did you say to the wire? Hi, Gary.
To the log, I was saying. Hey, Gary, welcome. We're starting at the very beginning.
We're proper basics.
And we're playing with cryptofex, since I think it's a good learning tool for people like Rich that want to play with Rholang and learn the basics. It looks like they have some pretty good documentation that goes along with these sample programs. So we just opened the examples here, and we can see we made a new name that's that is a channel that we can use to write to the log or the standard output, which is where the output the process is directed, whatever.
So I guess one of my questions here, I was just discussing with Jim, and I think showing that I do get how such languages are put together, and that I've done a bit of logic programming. So from reading Greg's paper, I'm aware that the new construction is an unforgeable name, and that is a quoted process in the row calc. So in that sense, I understand the new standard out thing. But because you need things like I/O bolted on to Rholang, I can also get my head around the fact that we've got some built-in functions that moves perhaps slightly away from the row calculus purist theory and allow us to do things like standard out. So I guess my question here would be row.io row:/io: standard out is a call to a built-in function in PowerBox. Is that much correct, Jim?
Yeah, it's a connection to the outside world, outside of the mathematics.
Got you. So and then the brackets I just take as the syntax for doing that. But is there any more to this than what we've just discussed, or should I stop worrying about any more because I've got the general idea?
I think you understand very well. Okay,
Thanks.
so we created a new name, and then that name is going to exist in some piece of Rholang code.
And those curly braces are the scope of its existence, are they?
Right, the scope. Right, that name standard out, which we could have called anything.
Yeah.
Is only used once in the line below, and then it goes away.
Got you. And in the line below, what we're doing is we're calling that name. We're sending hello world on that to that name on that name.
That's correct. The exclamation point writes the process to the name. That's in parentheses.
I see.
Following the exclamation point. So the parentheses is part of the syntax there. So it's exclamation point and then in parentheses what we want to send.
Great, which is all fine, except I've forgotten what I was going to say. I like what I was going to say and I can't remember what it was. So, yeah, I think, well, I can't remember, so I'll ask a different question. So, we're sending, I think we could say we're sending hello world on standard out, but could we also say we're sending hello world to standard out? And which of those two things is more correct, or is it a different way of?
We're sending a process. The only thing we do in Rholang is we send a process to a name. So the hello world, which looks like a string, is a very simple process in Rholang. The number 2 is a process, just like 2 + 2 is a process or whatever. It's a basic element, a very simple process, just the string hello world. And so we send a process to the name standard out. Now the name standard out is linked to the special output channel standard out. It would be better here if they gave it a different name so we wouldn't confuse it.
Yeah, no, I follow though. You're talking about the channel created by Row.
Take the STD off of there and just have it say out.
Yeah, so it makes it easier to talk about. thanks for starting right at the beginning. It's the way my mind works, so I much appreciate this.
Okay, so so that's all there is. So now we can hit the run button.
Yeah, just before I do, so the reason I'm kind of umming and ahhing a lot is, on the one hand, I'm trying to keep purely to the syntax, to the process calculus, the row calculus, and where we've got syntactical bolt-ons, built-ins, whatever you want to call them, in PowerBox. But then the other part of me, and I'm nowhere near as strong on this next bit, is thinking, how's that implemented under the covers? Is out actually an object reference or an address to which we're sending the hello world string? So
we can think of it as an address.
Yeah, that's what I was thinking. So I'm trying to think on two levels, and I realise I can't possibly guess everything right in my working model first time, but I think it's good to be trying to build up such a working model. Cool. So how do I run it? Sorry.
Okay. On the
Here.
right side is the run button.
I think I've got it.
It takes a long time. That's the first thing I know.
Yeah, no, it's thinking time. Wonderful.
Yeah. The early versions of cryptofex were faster. Whoa,
Okay.
we got an error.
I did, didn't I?
That's no good. Why did we get an error?
Sure. Maybe it's because it's on Windows. Should I put STD back in, or are you sure that's not a problem?
I'm sure that's not a problem. You can put it back in if you like.
I'll put it back. Just, it's what we opened.
Running it probably might have worked anyway.
Yeah.
I think I did get an error. Oh, no. Okay, scroll up to the top.
Yeah, I will do. I like what you did, so I'll just put it back like that now. We know it's not that.
Okay.
So that's the top.
Of the
error. Yeah, of course.
Oops. We got there you go. Okay. Unrecognized interpreter error. Go down to the bottom and see if it says anything.
Do I need to install like Scala runtime or anything like that? I would have thought it should do it for me, but all I've installed is and we are on Windows, so I presume a lot.
Too.
Okay.
Let me take the.
Yeah, please do.
See if it works better on my machine.
Yep.
Where am I?
Sounds pretty heavy.
This is amazing stuff. I didn't realize Susskind had solved quantum gravity in 2008. I'm
Wow.
still trying to, I'm still trying to convince people how it works when the really hard lifting Susskind already did. Okay, so we looked at.
I'm not interested, but I think that might be overloading me. I'm still struggling with Hello World Rholang. But yeah, I love my maths and consequently my physics too. So yeah.
Okay, well, it's amazing stuff. It really is.
With quantum gravity stuff.
Yeah, I mean, I've been watching this video and got a whole new understanding of the holographic principle, which I thought I understood very well. And I'm getting this error.
Mm-hmm.
That's something.
Maybe we just move on to a piece of Rholang that does work. Mind you, that should work, presumably. It's not to do with backward quotes on the row.io, is it?
No. Let's try another one.
By the way, Gary, I'm very aware this is very basic. I really appreciate Jim's help, but I'd love it if you stayed, but equally I won't be offended if you'd rather drop off and watch Hello World all over again.
No, I'm at the level where I lose it very quickly, so I don't mind this introductory stuff at all.
Cool.
Every time I do this, I remember something that I had been doing wrong or forgotten.
I agree with you. I think this stuff is so complex with so many layers and levels that repetition is not a bad thing, right?
No,
yeah, I think this is, you know, I mean, this example that I chose, fruit.row, introduces a number of new things.
Cool.
And it does run.
Oh, good.
They're not really that complex, so I think this is a good example to go over. And
Sounds good.
We're doing the same thing here. We're creating standard out, okay, and the name standard out, so we can get output from our program.
Yeah.
We define it in this context.
Yeah.
Where we have the name map test.
Okay. Simple process map test.
This name, this is a public name, which is very dangerous to use, but is fine for just playing around. We should have declared map test as an unforgeable name to do it properly.
Can I ask what? Well, yeah, I follow that we should have, and maybe we could look at that as an enhancement. But once we've gone through what is there and working, but why? Two questions. One, why is it a public name? And two, why is it so dangerous? What does a public name mean?
What we've done here is we've taken the process map test.
Yeah.
And we turned it into a name by putting an @ sign in front of it.
Yeah, I'm with that.
Okay, so
I'm not with why it's dangerous, but I thought that's what you did do.
Okay, and so anybody can forge this name. You could be writing your program and you could say @ map test quote.
Because it's on the stack in some way.
No, because it's the string, MAPTEST. Okay, you can type that in just as easily as me.
Ah, yes.
Okay, so you would be writing to your map test channel, and I'd be writing to mine, when we'd actually be writing to the same channel.
Okay.
Or reading from the same channel.
Which is clearly dangerous.
Clearly,
okay.
We're all sharing the same interpreter in a sense, is the way I tend to look at it.
Think of the machine as the Archain world computer.
Yeah, so think of the distributed Archain blockchain network that's chugging along, presumably with smart contracts. That's a separate question. Let's stick with the code. But think of it as a global computer for the purposes of this, yeah?
So I'm sending to that channel a process in parentheses. Where's the end parentheses?
Yeah.
Oh, right there.
Yeah.
Okay. So, and that process that I'm sending is a map. And these are all on the cheat sheet. The curly brace starts a map.
Yeah.
And we have the label A is apples, the label B is bananas, the label C is coconuts.
Sounds all good.
That's a mapping, from letters of the alphabet to fruit, which is the name of the program.
Cool.
Okay, so we've written to that channel. Okay, now we're going to read from that channel. And the 4 is not a loop, it's a read.
Yeah, thank you for emphasizing. I've got that now, and I think I understood from somewhere. It's a hangover from the way Scala implements it, and some people don't like it in Scala, but because this interpreter's built out of Scala, that's why we've got that funny notation, but it means a read. Correct?
Yes. And, I guess it's in mathematics or something.
Sorry?
Um,
I didn't hear you.
I think it's used in the row calculus mathematics.
Ah. Oh, okay. Thank you. So I'm wrong in that sense. Okay, thank you.
I think you may be right. I know the 4 is associated with some language, and it's probably Scala. I can't.
Yeah.
I learned so many languages that
It's impressive. But yeah, I get you. You can't remember everything, right?
I have to do a brush up before I do any Scala. Okay, so here this is the channel, the public channel map test, and this operation reads it. If the message on that channel matches this pattern.
Just say that again, if you would. Something reads it if. What reads it?
Okay. We'll read what's been written to the MapQuest channel.
Ah, got you. If and only if it matches the pattern on the left.
Correct. So this is what we're reading. We're reading something that matches this pattern. And this pattern is the name, and we always read into a name of a process that has a map in it. And this is the map. And
X and Y are channels, are names, right? Or
well, this is the pattern of what it's going to read. So
okay.
if the thing we set up here matches this, it's going to match it, and it's going to bind some names for us. So let's see. We're reading a map that contains a label D that we bind to the variable X. Well, we match that part of the pattern. This has a label B in it.
Yeah.
Okay.
So we'd match. Yeah.
We match that part of it, and then it has the label A, which we're going to bind to the variable Y.
Yeah.
Sure enough, it has a label A in it. And then it has ... tail. Okay, and ... says all of the rest of the elements. And you can use these with sets, and you can use them with lists, and you can use them with maps. It matches everything, all the rest of it.
Got you.
Okay.
So it's like you must have a.
The name tail gets bound to the map that contains all the leftover.
Got you.
Elements.
So that pattern match is basically saying must have a B on the key side, must have an A on the key side in any order, and then after that I'm happy, take anything else.
Right, take anything else and bind it to the name tail, T-A-I-L.
Ah. Oh, interesting.
The text will contain, okay, this does match the pattern that was sent, and X gets bound to apples, Y gets bound to bananas, and tail gets bound to the map with just one element in it. C, label C is coconuts.
Interesting. Almost like a start of a recursion or something. I don't know. Anyway, yeah. Got you.
So we're gonna
Pardon?
write standard X to we're gonna write the X to standard out, and then we're gonna write the pattern was matched.
Yeah.
Okay, and we see down here in the execution that it's evaluating, and what it did is it took out all the names we put in. Okay.
Yeah. Sorry.
Okay.
Yeah.
Because what names we did already, and internally, it just says whether it's using name 1, 2, 3, 4, or 5, whatever. It doesn't know the name. Okay.
Yes, you showed me. I think you showed me some. I'm going to call it intermediate language for want of a better word, but you showed me some. The interpreter in action or something, yeah, and we saw lots of X0s, X1s, X2s.
Right.
Is that correct? Yeah.
Okay, and then we see the string bananas put out to the log here.
Yeah.
And
As
that
expected.
Standard out X. Okay, which matched the thing that had.
Yeah. Why is there a pass?
Is bananas.
Yeah, I get that. I get what we're seeing, but this par button, not button, sorry. I've just noticed it's standard out X, par, new line, standard out, the pattern is matched. So they're being run in parallel somehow. Is that correct?
Yeah, both of these run in parallel. It's possible for us to get these in the opposite order because
Yeah.
the only way we combine processes in Rholang is we run them in parallel. So we might have listened on map before we wrote to it because these are done in parallel. But it doesn't matter. Okay, it'll wait until something's written, and if it matches, it'll run.
Yes, because this is deterministic because if there's nothing on map tests, the second part won't run. So you're guaranteed to have to populate the map test before.
Right.
And ignoring your comment about it being a public name. Yeah.
Right.
Cool.
Okay, so if we if it doesn't match, well, I don't know. It's about report. This will just never get run.
Can we comment out bananas? Sorry, comment out the line B:bananas and run it again.
Okay, I'm just running it again for the heck of it here.
Sure.
I don't know how many times I'd have to run it, but if this interpreter is running properly, this is non-deterministic, and sometimes it'll say the pattern has matched before it says the value of X.
Makes sense.
And it did it.
Well,
No, it did. Same order.
Yeah.
Okay, well, I'm wondering if we can move on.
Yeah, for me you can. Gary?
I was wondering.
Yes, move on. This is good.
Well, actually, I was thinking of moving on to our liquid democracy plus.
Yeah, that's what we're here for, right? So thanks for that aside. I appreciate it.
Okay, and we have we looked at the locker contract last time.
We did.
And
I'm not going to pretend I can remember everything we saw. The thing that stuck in my mind was when we had some sort of address and tuple, and that's because I'm kind of vaguely interested in our space and what gets written to the logs and things. But essentially, let's just cover whatever you want to cover, Jim. Bearing in mind, I basically can't remember anything from last time.
I'm having trouble here. Okay, I'm lining. Did I get that right? Yep.
I say I can't remember. I say I can't remember anything. I think what I can remember is that Locker generated behind the scenes a public key and a private key for an individual username. That was tied together through JavaScript, so the new user never really saw that. They just had a password, and essentially that public-private key would be written out in the Rholang logs somewhere, and therefore it wasn't actually secure, but it did do the job of being able to send something representing a mail. And I think I set up such a key for my username in Discord and used it to send and receive a mail. Is that roughly what Locker did?
Yes, this was a Locker contract.
Good.
And it uses, okay, basically the robot has to be made smart enough now to make signed messages. So the code is here is temporary, and one of the work study topics pretty soon will be doing signed message properly, which they're just changing. And but they're going to provide command line features for us to sign messages, which we can easily put into robot in order to secure these. Of course, people have to trust robot.
Of course.
At the same time, everybody can run their own robot.
Yeah. Clever.
They can,
So,
they can.
Is this related? Is this related to getting the RSign API, the RChain API working, and in particular the RSign?
Well, actually, they're recommending I don't use the RChain API right now, that I continue to use the command language, because they just developed those command line features and we're already using the command line. So our easiest implementation path is to use the command line for now. But we're also going to look at getting some of Josh's example apps, our RChain API, working again.
And is that a Java? Is that Java built in JavaScript or just in Rholang, pure Rholang?
That's pure JavaScript.
Got you.
Okay. He has a few sample apps, that are kind of educational. These are definitely worth going over. Okay, so so this contract. Contract Locker down here. Okay, we just gave it a public key, and it returned a locker, a name for the person's locker. And when that name, of course, has to be private, which is an unforgeable name that it gets it. And temporarily, we're storing that in the as a global macro. So, well, everybody knows it, but in principle, they can't sign anything, so they can't access anything.
Where's where's the unforgeable name? Is that self or something else?
Self, yes.
Yeah.
Okay, and using self, sending on the name self, they can update their locker. Okay, they can get the locker nonce, which is just a sequential number of accesses. It's part of the security. And they can get the contents of the locker. Okay, but they have to supply a signature to do it, which right now is not a very secure signature.
Where's the signature supplied?
I'm sorry?
Where is the signature supplied in the code?
When the signature is supplied, when you create the locker, when you create the self.
Yeah, I see it now. The
self,
away, right.
when you access the self with a get or an update, you pass in. Well, it should be a signed message.
I see.
Okay, and then we go down to SIG. Whoops. Okay, so we say if the converted signature is equal to the public key, then we gave a public key when we created it, right? Then we get the contents or we update the contents.
Is that buying equals sign? Is that equals or not equals?
If it's not equal, we fail bad signature.
Sorry. Yeah. Just all the code's new, just been done. Sorry.
Yeah, no, I wasn't clear there. Thank you. Okay, so so what you did, what we did last time was we ran that, and you ran a macro, make my locker, and if we go back to our where is it? Our robot testing channel here, and we do show make my locker. Oops. Commands here have a colon at the end of them. Okay, we see the code for make my locker. Which here it defines the standard out channel like we did before, and it assigns a lookup channel, which is a new thing. It's a lookup in the registry. What we want to do is we want to look up the name of the locker contract in the registry. And one of the things we did was we wrote it to the registry using an insert arbitrary. And that's the way we can take an unforgeable name and expose it so that we can essentially make it public.
Is this the global virtual machine registry? It's an R-chain registry.
Yes.
And
virtual machine. And it
gives
a URN, uniform.
Can I think
name.
Yeah. If I think of a GUID, that's what your URN is that right?
Correct. It's an identifier.
Got you. So I'm semi with it. There's a lot I don't know, including anything to do with JavaScript or web or really programming. But you can tell I get the idea about how these things work, sort of like internal robust applications.
Okay, so what I do is I assign the name lookup to the registry, and then I look up the locker address. Okay, and this is a macro in macro. It's not part of Rholang directly. When we define the locker contract, when we ran the locker contract, it defined to the log. Okay, so here we get this is a URN that we got back for the locker contract, and that's we have a name for
a reference to it.
Yeah, we have a reference to it that's stored in Discord, so that we can refer to it by name. This way, every time we redefine the locker contract, as we evolve these programs, we don't have to rewrite all our macros.
Didn't follow that last statement.
Current address of the locker contract. Okay.
Yeah. Okay. Sorry to jump in with the sides. I follow what the URN is, and that it's stored in some memory space of the R-Chain blockchain as a global registry. At least for now, that's how I'm viewing it. Does that relate to our space and tuples or not? Is it a separate memory construct or memory module?
I'm not sure exactly how it's implemented.
Fair enough.
As I understand, it's a sieve, right? Which I think is optimized because writing it in Rholang would be inefficient.
Makes sense. Got you.
It's probably, it's undoubtedly. It's a good question. I don't know where it's kept.
No
Okay.
worries. Let's move on. Yeah.
So I looked up the unforgeable name of the locker contract, and I send to the name lookup, which I bound to the service row registry lookup, the address of the locker project to be returned to me on the lookup channel. So
you've completed a lookup. You've just done a lookup with that code. Literally.
Right. Well, yeah. So when something comes back on the lookup channel, and that's the next thing I do is I read the lookup channel with it before.
Got you.
Okay. I said, okay, the locker contract name that I just made up this name here. Could be anything, but it's going to be the name of the locker contract that I'm going to read from the lookup channel. Okay, and then I output found locker, and I give the name of the locker as a process. I have to use the star here, the asterisk, to send a name as a process, because we always send processes and receive names. Receive the names. Okay, and So then I create a new
Jim,
some new channel.
Jim,
Yep.
I'm sorry to interrupt. I think, if I'm honest, I'm starting to get lost now. So I was with you when we had the lookup using the Powerbox row registry lookup.
Okay, and then and we wrote to the
Have we missed a bit? Insert row registry, insert arbitrary, ins channel in. What does that part mean?
Oh, the row registry insert arbitrary is the way that we store things in the registry. So I created the name insert, which I can
use later, but yeah,
okay.
Got you. So I see why you didn't mention it now. And then you've created a third name, ins channel, insert channel. And now we're moving into the Rholang code. Sorry to reiterate, just trying to do it slowly to make sure I follow. So now we're in the Rholang code, so you can reference your unforgeable name lookup, and you can send to it. Now, dollar locker, remind me what it was. It's a registry item, right?
Yeah, dollar lookup. Okay. By echo dollar lookup.
Dollar locker, yeah.
It's one of these fun things in the back quotes. A row ID, and this is the GUID.
Yeah.
For locker.
Got you.
Okay. So
okay, where's it parsed, or is it not?
I'm sorry?
Where is that colon separated string parsed?
Colon separated string.
At the bottom, dollar locker is a colon separated. Well, I'm saying it's a string. It's got two back quotes around it. It's got the
the back quote. Power box.
Oh, it's like a namespace, yeah, down to a URN.
Right. It's just like standard in. It's a power box function. It's an ID of a name.
Okay, I think I'm with you. Sorry to break it right now.
This is the locker. Okay, when we did an insert arbitrary to create the URN for the locker contract, it returned this value.
Okay.
This is the address where it sort of stores the unforgeable name of the locker construct.
Yeah.
Okay, so when we look it up, we get it back. Okay, and
yeah.
Dollar locker just puts in the current value, the current URN for the locker contract, which is this down here right now. Next time we run a locker contract, this number will change.
Got you.
And
that's your show colon my new locker that generated and looked that up. Yeah.
Right. This is
make my locker. Yeah.
Okay. So it had to find the contract first of all in order to call it.
Yeah. So sorry to slow you right down, but at least now
I think it's important.
I understand. I think. Yeah.
I think it's important that we don't take any step. I'm sure some people, if they're watching this later, have missed some steps. Just come to a work study, and we'll clarify it. Hopefully.
Thank you.
So this says this basically says you write a letter to the registry and say, I want you to send me back a URN.
And how's that?
Send me back an unforgeable name. that corresponds to this URN. Okay, so this is the channel where it's going to send us that unforgeable name. Lookup channel.
So I think I get what you're saying in that what we will get back will be that URN code, yeah? The long string.
No, no.
As a result.
No,
No?
we're sending the long string. We're sending the URN. We're getting
That's what I was thinking.
an unforgeable name. We can't write it as characters. It's unforgeable.
Okay, sorry. So, yeah, because of course we got the bang there. So we're sending on the lookup channel the substituted unforgeable name.
No,
This is a tuple, right?
Actually, the URN. The forgeable.
That's what I meant.
Yeah.
Yeah, sorry.
Okay. The URN is forgeable.
We're sending the whole of that.
And we're saying we want you to send us back the unforgeable name on lookup channel.
Okay, can I just check the syntax? So looking at that after the bang, it looks like a tuple to me, but it's not a tuple, right? So we've got.
Actually, you mean there's a comma here?
Yeah.
That's a funny question. I always assumed it was a tuple.
Right. Okay, so if it is a tuple, can we rephrase what you just said in terms of the tuple? So we're sending a tuple, maybe,
right?
Of which the first component is the unforgeable.
The forgeable.
Forgeable.
Right. We're sending it this value here. This is a value anybody can type in. It's forgeable. It's a URN. We're sending it the URN.
I got it. Yeah. It's an explicit string, and therefore forgeable, rather than, I'm getting my head around forgeable, unforgeable now, rather than a name whose content you can only access through in-scope code. Is that correct?
Right, you got it.
Good. So I still haven't got what the tuple is and why we've now got a process on the right-hand side.
We always write to the process tuples, a list of arguments. Or we almost always do. Okay, when we define the contract, we define a list of arguments that it's going to get. These are the things that it matches against and executes the code. So we'll look at that when we actually write the contract down here. We see we send it a tuple that has a public key in it and gets a result back on a locker channel. It has two arguments. Okay, and we look at the locker channel here. We see that we define it to see the pattern of two arguments, a public key and a return channel. And that's the way we call it here, and that runs that code. Okay.
Yeah, I think it's simple stuff. I'm not quite seeing it, but I think so.
Okay, so here's where I get the unforgeable name that I put in, that I looked up here, right?
Yeah.
Okay, now over here, in the locker, channel, I insert the unforgeable name locker and get a result back in the URI channel. And then I read back the value of the URI channel. And then basically I print it to the log. Now Robot in Discord sees this defined locker to this URI, and that defined $URI, that defines the variable $locker to be that same URI. But that's not a Rholang function, that's a Robot function.
Yeah. Okay, just to, so the key point here is, sorry, if you go back, if you could go back to the, yeah. So just looking at that again and trying to paraphrase what you just said, the reason something's returned on the URI channel is because you've just declared it. So
I insert it into the registry here.
Yeah.
Right.
So the locker channel already exists and has already been defined above because it must have, because
Right.
it isn't defined in the new URI channel. Yeah.
First thing we did was we created the name new locker.
Yeah.
Okay.
And populated it, right? With all that code.
Just a name.
No? Yeah.
We didn't do anything with it yet. We just put it on the registry.
On the registry, on the stack.
On the
registry, to be precise. Yeah.
Mobile registry.
Yeah.
Okay. We got back a URI which we displayed on the log for future use.
So sorry to pause again. So we got a new URI, not in the registry, but on the stack. Then we're dropping into some Rholang where you're.
Wait a second. We have an unforgeable name, not a URI. We have an unforgeable name locker. We don't have any URI until we come down here and we do the insert arbitrary.
Got you.
That creates a URI.
Something in the registry by definition from the namespace row registry insert arbitrary.
Right.
Okay, I'm catching up. Sorry it took a while. So yeah, so you're on the name insert arbitrary, which is actually calling a Rholang library namespace. You are sending the dereference process locker, which is currently empty, and you're getting
an unforgeable name. Unforgeable names don't have anything. Well, not yet until we listen for something or write something to them.
Yeah.
You have to read them or write them before they do anything.
So that's the empty process at the moment, is it, that locker? Or am I confused?
It's just a channel. It's not a process.
I thought the star may turn dereferenced a. Sorry?
Yes, we send the name as a process, right? We only send processes. So for anything, we can make a process out of it by doing a star.
Yeah. So I'm reading star locker and thinking that must be the empty process because we've not defined a process on locker, and yet we are.
It's like the number 2 is a process. This is a specific unforgeable name. Like the number 2 is a process, or can be a process.
Or what? Sorry, Jim.
It can be looked at as a process. Like 2, you can look at it as a name, or you can look at it as a process. So it could be a name or a process. It doesn't matter.
Okay, am I thinking that when I think of it as a process, am I thinking double quotes with two inside?
No, just the number 2 by itself is a process. Okay.
Okay, I'll go with that. Yep, no worries.
An unforgeable name by
Something I
itself.
need to do. Yeah.
Unforgeable name by itself is a name. Okay.
I got you.
If we put it in front of a 2, that makes it a name.
So I can think of this star as literally just moving the name 2, mapping the name 2 to the process 2, and they're sort of in different sets. If I think of a set of names and a set of processes, the unforgeable name locker can be mimicked in the process space via this star, and it's just the process called locker.
Well, we actually did. This name is only local here, so it doesn't really have a name. That's what we're doing, is we're giving it a name. It doesn't have a global name. And this name locker is only good between the beginning bracket and the end bracket.
Of course. Yeah.
So by putting it on the registry and getting back a URI.
Finally. Thank you.
Okay, then now we have, and that's, I understand the confusion there, because we're taking, we're taking an unforgeable name, and then we're giving it a name that we can use to get back the unforgeable names. So,
yeah.
That a lot of people are confused by it.
Yeah, I get my confusion. It's not just about the syntax. I've been thinking about Rholang very much along the lines of RhoCalc, but actually it could be a little bit more than just the row calculus here. You actually need to know about the implementation specific of putting something on the registry. And as far as I'm aware, that's not in the row calculus. Am I correct? Yeah. And that confusion removed, it now makes sense. Whether I remember it, I apologize in advance.
When you're writing row calculus, the names are local to the page.
Yes.
They don't go, X is different on every page, and there really isn't no way to carry the same name across the page except by, saying let P equal something from the prior.
Yeah, I follow.
Okay, the distinction between names and processes, I don't think it makes in the pure pi calculus. Okay, you have channels and messages. The messages are processes, whatever. But I don't know. But in essence, because when we define a contract, like when we go down here and we define a contract, what we're really doing is we're reading on the channel locker this pattern. So now we're reading the channel. So if somebody writes to it, we have this read sitting there waiting for somebody to write to it.
Yeah. So if they send a pub key that is a byte array and they send something to the return channel, this contract can start executing.
Correct.
Sorry to not let you get past the insert arbitrary, but could we? Could I ask one more question on it before we move on?
Sure.
Sorry. So I get the locker going in now and being written to the registry, but you said there's something returned on the URI channel, so I just wondered what that bit was. So the second part of that tuple. So insert arbitrary is a call to a PowerBox function, which must basically write to the registry. And then what does it return on the URI channel?
Okay, well, we read the URI channel, and then we define the URI. Okay, what it returned was the URI. It returned this PowerBox name, whatever, row ID, and this GUI.
And that's just what the function does. Got it. Okay, yeah, let's move on. Thank you.
Okay, so now, even though this locker variable goes out of scope, we can get it back by doing a lookup in the registry.
Makes sense.
URI that it returned.
Cool.
All right, so so here we get the URI. Given the URI, we get back the unforgeable name that we had, and we're going to call it the same thing, locker. Okay, we're just giving it the same name. We could have called it anything.
Sure, got you.
Okay, and it found it, and it prints that it found it, and too bad Gary left before he make my locker. I wanted to show an example of locker.
Have I not got a locker? I think I've got one set up from last time.
You've got one set up. I guess it wouldn't hurt. Not really going to hurt to do it again.
Sure.
But I don't know how long we want to go. But in any case, I call it with two arguments: a public key and a return check for the locker. Okay, which matches what it's reading, and then it says made locker. Okay, and now it inserts.
She defined earlier.
It inserts. Where's the read?
Is it not after the par? You've got a four comprehend.
Okay. Okay, from the locker channel, it reads back the unforgeable name of the locker, of a specific locker, of my locker. Okay, so from the locker contract, I got a locker back that it made. That's the name of the locker. And that name, which over here is called self, over here I call locker.
Okay.
So now, in order to use that locker, I need to be able to call it later, tomorrow. Okay.
Yeah.
So I'm going to insert that also into the registry, the URI that I got back for my locker.
Cool.
Okay. And then I read back from the URI channel, the URI. Okay, the name of the process URI, because I put an @ sign in front of it.
Sure. I'm saying sure to allow you to get through the program. Just as a quick pause point, thank you for all the above, because what I'm going to do is spend an hour or so looking at the code, because I think you've given me enough that I might be able to decipher it now. So for the benefit of everyone else, I'll let you just move on. I'm not following everything you're saying, but let's get to the end of the program.
Okay, I'll breeze through this. Anybody can look through it on their bed sheet. I mean, here we're printing out the URI. We're sending to the standard out. Really, in this case, a list which says define the locker, and this ++ is concatenation. And the robot puts in my username, which is Jim Scarver here. So if I do now, or I can just do the show. Show locker underscore Jim Scarver. It shows me how that's defined, which is this URI that it got back for my locker.
From the registry.
Okay, and if you run it, it'll be your locker, right, from the registry.
Just one question on that. The hash, sorry.
Yeah, when you robot substitutes your username here when you run this instead of my username.
Got you.
So for me, it's Jim Scarver. For you, it's Rich. Right?
Is the hash defined like, it's been a long time since I wrote NEC, but like the hash, I can't remember what you call them even, but you have hashtags, if you like, in your C code and the headers, and for basically they represent a load of text, right? Is that right, or am I thinking of that incorrectly?
Yeah, the macro processor that robot uses is actually the same one that C code uses.
Right, and it's so pre-processes and drops in the $locker nonce and the $my username.
Right, and
yeah,
$locker, and it defines you. This also creates an inbox for you.
Oh, what? Sorry.
This also creates an inbox for you. Okay. So,
okay.
So you want to type. I don't know how much detail I should go over here, but
it's up to you, Jim. I have time, but I don't want to keep you if you need to get on with your day.
Yeah.
We can just talk it through rather than do it, if that's easier.
Yeah. So it defines the locker. Okay, and then it looks up the inbox contract. And it writes to the inbox contract to create a set of capabilities. And it returns, in essence, a tuple of capabilities. And these capabilities for an inbox are receive, send, and peek. And it reads those from capabilities.
Which is a different set of reasonably complex.
Return channel for the inbox contract.
Yeah. But we've not looked at what defines the capabilities process, have we?
Well, the capabilities is just a name. I mean, we haven't looked
okay.
We haven't looked at inbox.
I see.
Okay, so inbox returns a set of capabilities. It makes a new read, write, repeat capabilities and a box, the actual mailbox. And then it returns those names, read, write, peek. And then it defines, if you send to the channel read, a return channel, it reads the items in the box and it writes to the return channel the items. And it puts the items back in the box.
Yeah.
Because once it reads them, they're gone.
Okay. If you didn't put it back in the box.
Hmm?
If you didn't send it back to the box.
Right.
So they're not. So you're making sure they're not gone with that box sent to the box, yeah?
Yes. And also, nobody else can change the box while it's empty. They have to wait till you write it back before they can read it.
Yeah.
Or if they try to read it, that'll just wait until they write. Until you write.
Yeah. It's quite concise, isn't it? I like it.
Okay, so we define what all these capabilities can do.
Mm-hmm.
Okay, and then um, uh, we update your locker. We do a locker update, and we put in your capabilities, because only you can get them out of your locker. So if you read your locker, if you do a get from your locker, you'll get these capabilities out of it. And it's a
Okay.
and it's a map, so you can add things. You can you can keep.
I think I get the gist. What's the underscore in the next 4 comprehension on the line below?
The underscore is, I don't care what the name is. Read from the return channel. And it's really an acknowledgement. We usually call it ACK or something. I'm not looking to get value back. I just want to know when it's done.
Got you. So you don't care what the value is. You just want to know that a value was received. A bit like a return code.
Right. In other words, I'm going to put these things in the locker. Take all week if you want. Oh, wait. No, wait for the return channel. Wait for the return to make sure it's finished creating the locker. That's all. I want to make sure it's done creating the locker before I try to
Before you send a message telling me that it's all right, you want to know that it is all right. Correct?
What is this? Let's return. Okay. Oh, this means, wow. Okay, so what I did here, well, this was, I guess, actually Dan's code. What he did was he didn't bother to make a new name for return. But return is still in scope here.
Yeah. So what's he using it for?
This is very interesting because I don't know how, right now, I don't know how this works. Okay, what it's using this is to define my inbox. And this might be my code. Yeah, this thing is my code. But when I type make my locker, Found a locker, making locker, made locker. Locker nonce gets defined as 1. I do a locker update and I put in my capabilities. Inbox, peak, receive. I define my locker at this address and my inbox at this address. And what's confusing to me, what I don't actually understand here, is here I read from the channel, so the channel's empty. And then I take okay, I got the URI here. Okay, now I know why I did this. I don't want to define if for any reason it doesn't finish making your updating your locker because there's a bug in the locker program, probably. It's the only reason I'm doing this. I don't want to define your inbox unless it's actually finished. And then then I insert the URI. I get the URI back for the send because anybody can send to your inbox, right?
Yeah.
You want that to be public. And
yeah, because send's hooking into your capabilities. No, your inbox contract that you showed me a bit ago, right?
right.
Yeah.
The send lets you put things in the box.
Yeah. It's a great example, Jim, as well as being the start of building this liquid democracy thing. It's kind of self-contained. It's got some complexity. It makes sense. Thanks.
Right.
Just I hope it makes sense.
A mechanism to send capabilities to one another. And
yeah.
the mailbox is the basic thing that we can do. Let's see.
So what's the URI? Is the URI here the URI of the inbox, or is it a URI of whatever was sent?
The URI of the inbox.
I thought so.
You never what was sent is just sent on nobody. You don't want anybody else to read your inbox. They can only write to it. They can't read from it.
Makes sense.
You don't want to.
Yeah, I've got some work to do, but I think if I can remember everything you've told me today, which is a challenge in itself, I think I can have a go at trying to read the code now over an hour or two, and I will do that. So thank you. I don't know when yet, but I will have a look before we reconvene. Sorry, you did something else. I'll let you finish off.
Oh, that's all right. We basically went through all of Make My Locker. Okay, we didn't go over the inbox in detail, but basically, it's a place I can send stuff to you or whoever. Now,
yeah.
Technically, we expect that we have inboxes for all these people, but in reality, the URIs for for most of those people, except you and me, are out of date.
Out of?
Out of date. We have new
Okay. I get you. You've updated the code.
Right. We've had an updated code, and they have to make new lockers. Well, actually, it's not the updated code so much. It's the the upgrade of our chain itself. Okay, the old code still works for what it does, even if we've improved the code. You can still send to somebody's old mailbox, but they wouldn't have all the functionality maybe of the newest inbox.
I see.
And I don't think inbox has changed that radically, but our chain has. And so basically, when we have a major release of our chain that will change, or when something happens, we hit a bug and our space gets screwed up.
Yeah, some sort of, yeah, I've kind of followed.
Okay, then we
so underneath the registry perhaps is the actual R space, and that might have changed. So therefore, trying to retrieve things might not come back. Is that what you're saying, or?
Yes, there's some error conditions where we might not be able to find things in the registry. Yeah.
Fair enough. I think one final question for me, well, two actually. One is, could you post this video somewhere I can see it again? And then, in addition, I presume the commands and things that you've put into Robot, I could do the same, could I, if I wanted to?
Absolutely. Okay.
Yeah, and do I do that under Robot testing, or do I need my own little area?
It's best to do it in Robot testing, where
Yeah, I'm comfortable with that. I don't mind people seeing my mistakes, as long as you don't mind me running a lot.
Well, the thing is, people can help each other if they see,
That's great. Yeah, sure. And of course, what the useful stuff you've just done is on the video anyway.
Right.
So for reference, if I want to play around with and run some of the commands you've just run, like maybe not make my locker, but whatever else, show locker _rich, I can just click on the Robot testing channel and type that in as you have, and that's fine.
Yeah, I don't think we have pinned items here. No, we don't. But if you go in the Robot channel, and you go to the pinned items here, okay, well, you get this basic. You're going to get, see this basic cheat sheet, which is
right. Thank you.
Which shows what the commands are.
Wonderful. Thanks.
Okay, and I think more importantly is this document. Okay, well, there's a couple articles published, but this is supposed to be the most up-to-date information.
Got you. Could you just drop that into the chat while we're on, just so that I've got the actual link in case I fail to find it?
Okay, I'll put it in the chat, but just hit pinned items in Robot.
Pinned items in Robot, thank you.
But you'll see in here the same table.
Wonderful.
Okay, and examples of all the commands.
Brilliant.
Okay, and
I don't know when I'm going to find time, Jim, because I'm pretty busy till we next meet. I'll attend the Rholang session as well, but I'm talking about next week. I've got to fly home and various things, but I will try and find 2 or 3 hours of quiet time to go through everything you've explained today, so that maybe I can actually start to have it sink in. Thank you very much.
Sure, you're welcome. And I'll post the video. Take care.
Lovely. See you tomorrow, maybe. If not, then next week. Bye.
See you tomorrow. Yeah, it's busy. We got government. We got
Rholang hour, is it?
governance at 6 p.m. New York. Okay.
Yeah, I'm not sure I can do that. I'm out tomorrow night. Sorry. I thought we had Rholang hour tomorrow.
Yeah, we have Rholang hour 11 a.m. New York.
Yeah, I will try and be there for that. Thank you very much.
All right, guys.
Bye.
See you tomorrow.